Hello, and welcome to another episode of the Solfate podcast,
Hello.
where we chat with founders and builders in the blockchain space, mostly Solana, hence the Sol in the Solfate. We had a really awesome one today. We talked with Nico from Elusiv, and holy cow, is that an important app? Like,
my goodness,
I actually
yes.
don't know why. Well, actually, we talked about maybe some of the reasons that it's not just like standard right now, but I think it will be in next like 12 to 18 months. It'll just be normal to do everything through Elusiv.
Absolutely. Like I basically fanboyed over Nico and everything that Elusiv is doing. Like I find it personally.
You're turning into me.
And I am. Nico is my favorite person, my new favorite person in the Solana ecosystem. No, I mean, like if you've never experienced Elusiv, you don't understand what Elusiv is as a ZK based privacy protocol on Solana. Like those are some buzzwords right there, right? And people think ZK and they think mixers and Tornado Cash and government sanctions and blacklisted wallets. And those things absolutely exist. But Elusiv is different. For one very important, I mean, for a bunch of reasons, but one very important reason is that as a privacy layer, Elusiv can actually be compliant with government regulators. They can be anti-money laundering law compliant with governments around the world because of how they handle the ZK stuff. That basically, and we talk about all of this in the episode, there's like kind of like a DAO voting system where people can propose a bad wallet address that did some illicit activity, did a hack, stole some funds, whatever. That can get sent into this network of wardens, which do a bunch of computation and can basically spit back out they can basically unmask a bad actor and only the bad actor, which makes it so powerful. Like
and all done in a way
cool.
that like ensures that no one person can unmask
Absolutely.
anyone, right?
Absolutely.
It's like no one warden can unmask anyone. It requires broad consensus that this is in fact a bad actor, and here's the trail that we have showing that this is a problem, and we need to continue to see this trail, not only just for government regulators, but like Nico brought up, that also just like how often is there a hack and the community comes together to try and like track that person and trap those funds in some contract so that person can't, make off with everybody else's funds. It also facilitates that in the community, which is super awesome. But anyway, let's dig into it because Nico explains this probably better than we can. So let's jump into the episode.
Yeah, and before we dive into this episode, we're excited to be sponsored by Underdog Protocol. Underdog Protocol's APIs make it possible to effortlessly mint, manage, and index your digital assets on Solana. And let's go ahead and get to the episode.
All right.
Nothing in this podcast is or should be considered financial advice. Any opinions and thoughts expressed are solely those of the individual. They do not represent the opinions of any entity. Enjoy.
How'd you get into crypto, right? Like what's your crypto origin story? And depending on how long that's been, maybe a little bit of like, what were you doing before that? Like kind of talk about the transition phase,
Yeah, for sure. So yeah, I mean, the way I got into crypto ties pretty closely in with the way I got into software engineering in the first place as well, which is like most technical people who start out usually when they're, a teen or a kid, and they have some like little kid project that they want to do to solve a problem. So in my case, I wanted to build a carpooling app for my school, which I did together with a friend, which, we built it locally, wrote the worst code that I ever wrote in my life. I still have it on my GitHub privately. I look at it from time to time and just weep. But basically, but yeah, so we built that thing. And then once we got it running locally on our computer, we wanted to deploy it so other people could use it. But then we noticed that we have to pay for things like web hosting, domain names, SSL certificates, and stuff like that. And so basically I thought I don't want to pay for all that stuff. So I started Googling around how to host website for free or something stupid like that. And this basically led me to finding people who were like, oh, you can host on your own computer, which you shouldn't, but and so basically I started Googling how to host on my own computer, how to host on other people's computer. And basically in the span of an afternoon, at some point got to how to host website on network of computers or something like this. And by complete coincidence, that made me stumble across Ethereum, even though IPFS probably would have been more useful for that use case. And basically when I read Ethereum, instantly I thought it was the coolest thing I had ever heard of. just because I had heard of Bitcoin previously. This was like, 2015 or something like this. And I heard that you could use Bitcoin to transfer money, but at the time I didn't think it would be that useful yet. I couldn't imagine that many use cases for it. Because I thought, wait, you can just transfer money on the internet using PayPal or a bank account or something like this. But when I heard about Ethereum, which was like you can run any program on a decentralized network of computers, I just thought that was the coolest thing ever, especially with the combination that, it's immutable, it's decentralized, and at the time, I thought, naively, private as well. Because, when I checked the Block Explorer, everything was hexadecimal strings, and I thought, oh, that must mean it's private, which it wasn't. But yeah, that's basically how I got into crypto initially. And I dropped that corporate project and started working at an internship for a company that at the time was doing what the Solana saga does today, which is deploying private key material inside of TEEs, inside of phones. And essentially through that, unfortunately, it wasn't that successful. Doesn't exist anymore today. But I got to work with some amazing people, learned tons of stuff about how blockchains work, how the cryptography behind it works as well. And most importantly, also learned that privacy on blockchains isn't a given and usually isn't a thing that exists at all. So yeah, that's basically my origin story of how I got into crypto in the first place.
That's awesome.
That's a great story. I love that.
it is a super fun one, right? Like I like the finding it of your own volition almost is super cool. I feel like a lot of us come from someone told us about it, but you sort of like tracking it down on your own and on your own realizing like, hey, this is really cool. I want to dig into this a bit more. Super, super fun. Can you give me a sense of like time frame for this? Like when was this happening?
Yeah, for sure. So yeah, when I first stumbled across Ethereum while building my website, it must have been like 2015-ish, something around that time. And then when I worked for that company that was using TEEs to secure key material, that was like 2016, 2017, something around that.
Nice. And then, I mean, the logical next question then is sort of like, is Elusiv, right? Is like, well, somewhere between then and now, you sort of already alluded to you caring about privacy on chain, right? Like even at the beginning, you sort of thought like, oh, great, this is private. And then later realized it isn't. And so there's somewhere between then and now, there was like this, hey, I want to solve this problem.
Yeah, for sure. So yeah, the way that went is I was working at that blockchain company, did that for like a year and a half or two. And then after that, basically, was done with high school and decided to go off to uni here in Germany. And there is where I actually met Yannick and Julian, two of my co-founders, because we founded this blockchain interest group together where we would just meet up with some other students every once in a while and just talk about like what's new, what we're building on, participate in some hackathons and whatnot. And then this is toward the end of 2021. At some point, Yannick joined, who's one of the co-founders, joined our group. And so Julian and I decided to take him out for dinner to a restaurant and just chat about blockchain. And at the time, and still today, the hottest blockchain was Solana. And so we were telling him about it, about how it's so fast, so cheap, so great overall. And so Yannick said, hey, how about you pay me your part of the dinner using Sol? Then I can have some of my wallet and I can use it to try out a couple dApps. And I was like, well, if I do that, then you can see all my activity and I can track all your activity and that's, permanent forever. And that basically got us thinking, we clearly care about privacy and some solutions for privacy already existed, such as Monero, Zcash, things like that. But why didn't we use them? And essentially the three main components that we came up with that were basically holding us back from using them were on one hand, cost/UX, composability with existing applications, and compliance, basically. And yeah, happy to chat more about like how we're thinking about those at Elusiv in length. But just to finish out the little story, we essentially said, okay, let's try to solve this just, with a little prototype. So we built out over the next 2 or 3 months, a little prototype of Elusiv to allow you to privately send funds on Solana. Posted it on Twitter. This is like beginning of 2022. And got a couple of people on Twitter being like, oh, this is very cool, including some people from Solana Foundation who told us that at the time there was the Riptide hackathon going on. And so they said, hey, you guys should participate. And maybe you guys could come to the Miami Hacker House too, which was in April 2022. And you could pitch your project there. And so we thought, yeah, let's do it. And we flew out to Miami, met a lot of the Solana community, which made us even more motivated to continue building, especially noticing how supportive this community was, especially compared to Ethereum, which felt a bit more isolated, which is what I had worked on previously. because I remember we came to Miami and there was Anatoly walking around there. There was Austin. And we just walked up to them and we were like, hey, we're building privacy on Solana. And they were like, super cool. Tell me about it, which shows, I mean, still today we look up to those guys, but back then, even more so, we were like, oh my God, they want to hear about what we're building, even though we're not even live yet and we just got started. And yeah, on pitch day, we ended up pitching it in front of a big crowd and actually got, a lot of people standing ovation. And when we came off the stage, everyone wanted to talk to us. And that's when we realized, okay, this isn't just a little hobby project. This is something that people clearly need and want. So we decided to pursue it full time. And yeah, have been going ever since.
That's phenomenal. Yeah, I remember hearing the first time I heard about you guys, there's tons and tons of assorted privacy solutions across the blockchain ecosystems, plural. And I was like, oh, okay, a ZK thing, like privacy is important, but also compliance is just like Tornado Cash is the perfect example of this. Like for the listeners who don't know what Tornado Cash is, which I'd be surprised, but like basically it would be used for potentially illicit funds, and anyone who used Tornado Cash, because it's considered a mixer by many governments, you get effectively blacklisted on your wallet, and you're on a government list somewhere and says you can't ever use anything, you can't use that wallet on a lot of things anymore. And then when I heard about Elusiv, I was like, okay, it's a ZK layer, privacy layer, that's cool. But, no one's really done anything with the compliance aspect of this type of privacy on chain. And then people were like, oh no, but Elusiv they have a solution for that. And I was like, oh, tell me more. So that's actually one of the things that I'm most excited to talk to you about is that compliance layer and like how it works technically. And our audience is generally pretty technical. And so I would love to know, to segue into like kind of like what is ZK broadly, and like how does zero knowledge technology on blockchain work at a high level? And then I would love to dive into the details of how that compliance layer actually works and how a protocol like Elusiv can actually use ZK but still be compliant in all of these different ways, and especially with like anti-money laundering laws around the world.
Yeah, for sure. So yeah, to start from the top. What is ZK, or how is it applicable to blockchain privacy? To me, this is still a really interesting concept because generally speaking, when you think about why are blockchains public in the first place, it's not because when, Satoshi and all those guys came up with Bitcoin initially, they just thought, oh, privacy isn't something that people need. Obviously not. I mean, they were all cypherpunks. But it was more so because at that point, it was more, you had a trade-off between saying, do we want things to be verifiable or do we want them to be private? Because basically you had the traditional banking system where things are private to some extent, private in the sense that I can't look what Nick and James, your guys' bank account balance is because it's saved in some bank's database somewhere. And unless I work for the bank, I can't really read what it says in there. But of course,
it's more
not fully
gate-kept
private.
device private.
Yeah, exactly. And so at the time when Bitcoin was invented, there wasn't a way to get around that. It was like, if you want to make sure that no one's cheating, which is what was the worry with banks and still is today, then the only way you can ensure that is by allowing everyone to verify the state of the blockchain and making sure that no one's moving funds back and forth and going against the rules. But that's what makes ZK so cool, because the two things that zero-knowledge proofs enable is, on one hand, verifiability. That's what they were initially invented for. But at the same time, hiding certain amounts of data as well, which means that using ZK, you can actually prove things about the blockchain without needing to reveal everything about it. And that sounds somewhat abstract, but the way most blockchain systems work today, or most blockchain privacy systems work today, is by simply leveraging this basic idea of saying we have a shared, essentially, with a smart contract. Everyone can deposit into this smart contract, and they can deposit a certain amount of money into it. And later on, they can prove they own that money without revealing what their initial address with which they deposited was. And that essentially gets you privacy in the sense that people can see Nico deposit into the smart contract, but later on when funds flow out, people can only see a ZK proof triggered this, but they cannot see essentially where those initial funds stem from. So that's basically the high-level overview of blockchain, how the privacy works. I'm not sure if that was fully clear. Let me know if I should elaborate on that. Yeah.
No, I thought that was great.
I'll just repeat back to you sort of what I understood,
Yeah, for
right?
sure.
Just to make sure we're all on the same page. Fundamentally, right? ZK, zero knowledge, as it applies to blockchains, is a way to say, hey, I'm going to be able to surface a proof about something. We'll keep it abstract for a second. Using some anonymized piece of information, right? So the example you gave is a lot like how Nick was saying, like Tornado Cash, for example, works. Is you can deposit money into a contract, so people can see that you have interacted with Tornado Cash, for example. But then when you go to withdraw, you were given something at the time of deposit that allows you to sort of prove that you own that deposit without providing without tying it to your address. So you can sort of withdraw from a different address using that proof. And that way no one can connect the depositing wallet with the withdrawing wallet. So you've basically created an anonymized wallet for yourself.
Yeah. Yeah. Well,
the problem there, right, which is this is just sort of leading into the compliance issue. The problem there is it's entirely anonymized. And so there's no way to know whether there's no way for compliance officers, for lack of a better term, to know who's who. So if they've found a wallet that's participating in malicious behavior, there's no way for them to find out who you are, and they want to be able to do that, right? Like that's a big thing that banks do, is sort of know your KYC, know your customer, right? So if we're going to facilitate all kinds of financial stuff in a private way, we also need to be able to prove that you're not doing something malicious for compliance officers. And it sounds like Elusiv has a great way to get around this. And that's what I think Nick and I are super interested to learn more about.
Yeah, for sure. And I mean, I think just to piggyback off that, like what's, I think even more important is that not only banks don't have or compliance officers rather don't have a way to verify that you're not doing something bad or something like that, but more importantly, and this is the big problem that Tornado Cash has, is if you have a public address and you hack a smart contract with that or do some clearly malicious activity, traditionally, if privacy protocols don't exist, everyone can see, oh, okay, this guy hacked this protocol, and we can see this is where the stolen funds are right now. They're inside of this address. And even if you move it to a different address, everyone can still see that. Problem is if you use Tornado Cash to then try to move it to a fresh address so that people can't track your trace, you basically screw over everyone else inside that shared pool as well. Just because as soon as the funds get deposited in there, any withdrawal from that Tornado Cash pool, an outside observer can't be sure if that's just a normal guy withdrawing his money or if that's the hacker trying to withdraw his money to a fresh address. And traditionally, there's a couple of ways that people have tried to essentially fix this problem. The most common one is basically blacklisting, which is what a lot of other protocols do as well, which is basically where you say, together with my privacy protocol, I maintain some sanction list or blacklist or however you want to call it. And basically, whenever someone tries to deposit into my protocol, I check, are they inside this list? And if they are, then I reject them from depositing. And there's different variations on this as well. For example, there's some a little bit more advanced ones where you say, oh, you instead say, oh, when you try to withdraw from Tornado Cash or whatever protocol, there you generate a zero-knowledge proof that you're not a part of some sanction list either. But at the end of the day, all of them rely on having some list where it says these people are bad and should not be allowed to interact with the protocol. Now, the problem is keeping an up-to-date blacklist is extremely difficult, or I would even wager to say borderline impossible. And the reason for this is that, on blockchain, funds can move extremely fast, which is very good. But in this specific case, has some downsides. Because it means you can deposit your funds into, a shielded privacy protocol, and then basically transfer them to someone else within the protocol or take them out before a blacklist maintainer can react. But even if we would say we have the ideal case of having some super smart oracle that can instantly see the second that some malicious on-chain activity happens, they instantly act to the blacklist by having some super MEV optimized whatever. Even in that case, you're not fully safe. Reason being that off-chain malactivity also exists. For example, a couple months ago, Chainalysis published some report where they found out that like a group of Ethereum addresses had been used by the Mexican cartel to sell drugs to one another. And the thing is, they discovered this like months after the transactions occurred. And in this case, a blacklist wouldn't have saved you, even if you can recognize any bad activity on-chain instantly. Because at that point, it would have been, if they had used Tornado Cash, for example, they would have deposited into the protocol. And then months later, chain analysis comes along and says, oh crap, these guys are depositing Tornado Cash. Turns out they were bad. And basically from that point on, you have to say any funds that flowed out of the protocol could have potentially been, those bad funds, so to say. So the other more, less popular and for good reason approach to try to solve this is KYC or variations on it, like ZK KYC stuff. Problem with KYC is obviously that on one hand, it destroys UX, and on the other hand, it kind of takes away from the trustlessness ethos that blockchains are all about. And most importantly, you can still get around them to some extent if you have enough at stake, because you can, to some extent, just bribe someone to KYC for you. And the problem is that in a privacy protocol, there's no way whatsoever to revoke privacy once it's given. Because if you would take this approach with a traditional bank of trying to game the KYC by, making someone do it for you, at some point the bank would find out and then they can freeze your assets because they themselves still know where your funds are or where they went. So for this reason, we decided to come up with something else, which we call Zeus, which stands for Zero Knowledge Encrypted User Safeguarding. And the idea behind Zeus is basically that we want to provide optimistic privacy, sort of similarly how optimistic rollups or just optimistic confirmation work in traditional blockchains. And to describe it at a high level, the main idea behind Zeus is that we say anytime someone deposits into Elusiv initially, we basically assume that they're a good actor. And you can just transfer within Elusiv, transfer out of it, call other protocols. We can talk about more about the capabilities of Elusiv afterwards. So you can use Elusiv normally without any extra steps. However, let's say that you are a bad actor. In this case, we have the ability to have anyone, be they a part of Elusiv, be they some random address, make an on-chain proposal where they say, hey guys, I think that this address that deposited into Elusiv at, using this transaction, I think that they're malicious. And of course, you can provide off-chain some additional information where you say, I think they're malicious for reason ABC. Then we have an on-chain network similar to like a DAO, for example, that can vote on this proposal and say, okay, yeah, we agree this guy's malicious, or no, we don't agree they are not malicious, for example. And taking the first case, if they say, yeah, we agree that they're malicious, we have a final set of nodes that we call Wardens. And these basically run NPC computations that allow them, provided essentially that this on-chain consensus is established, to decrypt transactions related to that one specific depositor. And that's basically the high-level idea of saying that initially, you can use it normally, but there's a certain contestation period wherein your privacy can be revoked to some extent. And of course, this probably raises a ton of questions in your guys' heads about how this works with trustlessness and things like that. Happy to dive into those as well.
I'm super curious.
All the questions.
I'll let Nick go because I know he's been thinking about a lot of these, but if he doesn't hit on my question, I will ask it after.
Okay. All right. Yeah. So it's incredibly cool. Like I think everything ZK is just super cool, mostly because I don't really understand how it works at like the technical level. So I'll take a James approach. Let me summarize. You can say it,
Nick. You can say math. You can say.
I definitely don't understand math. I struggle with math a lot. It's a real problem, in the United States. But you derailed me. Oh, I'm gonna pull a James here. I'm gonna say back to you what you said to make sure that I fully understand it, and then I'll ask my question. Yeah. So and we'll go through the route of if the collective Solana community says, hey, we think this particular wallet address did some malicious thing, like they hacked a protocol, drained a bunch of funds sort of scenario. So anyone can propose to this DAO that will effectively vote on yay or nay if this particular address, based off of maybe like a transaction signature or whatever information gets provided, if this particular address is bad, they did a hack, they participated in a hack, drained some funds. That gets it. Once that is approved, the wardens, which are not on chain, they do MPC, multi-party compute. Only if that DAO approval is approved, only then these wardens can then decrypt and unanonymize, if that's a word, and they can unanonymize the private transactions that went through the Elusiv protocol, but only for that specific address, the bad address that the DAO voted on, said, yes, this is a bad address. The Warden nodes can do whatever computation they're doing, reveal basically the trace of funds for that particular address, say, hey, it came into the protocol here, it went out here, and then now it's out of the protocol. Everything's now public. Anyone can continue to track it accordingly. Is that the gist of it?
That's the main idea. Yep.
Okay. So cool. Many questions. The first one is, what does that DAO vote sort of look like? Is it just some sort of Realms DAO sort of vibe, like typical DAO voting? A bunch of people vote, reaches some threshold of approval, and then if approved, it just goes, and then everything else trickles down, and then happens.
Yeah, for sure. So about that DAO vote specifically, the interesting thing about this is that there's a reason we made this modular in a sense, to have the proposal thing be different, the vote on it be different, and the actual execution of the decryption all be three separate parts, for the reason that the DAO vote itself can potentially be swapped out for a different piece to find consensus in some other manner about a specific proposal. And the reason that this is a potential route that might be interesting to keep in mind as well is that, as you alluded to a little bit the way you described it, DAO votes, unfortunately, historically, kind of have a problem that a lot of people don't participate in them, or rather that they take a long time to actually go through. So for that reason, we might have a slightly adapted system in the sense where we say, for example, we might have some automated system where we say, if everyone votes on agreeing that any proposal by, let's say, Chain Analysis or Nansen, people just have a way that they can auto vote on proposals by these people, for example, that are sort of trusted by the DAO. But outside of that, it would be, as you described, more traditional DAO voting. But we have some ideas for optimizing it a little bit to remove the traditional slowness that is often the case with governance proposals.
Oh, that's really cool. Having like an automated, effectively like accepting some trusted authorities of like, yes, this particular security research group is, they always propose, they've shown a track record of proposing good proposals. Like, we will trust their proposal. That's pretty cool. Okay, so the next part is the Warden. How does that aspect of the decryption, the de-anonymizing of the transaction, like what is a Warden? How does that work? And how does like the actual decryption and unanonymizing part, especially with it has to be approved by that DAO vote, like how do those connect?
So Wardens at the end of the day are just computers that basically run these NPC computations. And of course, the question is, how can we enforce, and how does this NPC stuff actually work a little bit more on the technical level? And the way it basically works is that we say, for the Elusiv network, we essentially sort of have a key pair that essentially encrypts every transaction flow from every private transaction. And basically the way this key pair works is that the public key is obviously visible to everyone, but the private key is sharded across this network of wardens, basically, meaning that each warden has a little piece of that belonging private key to that public key. And the way this is sharded is in such a way that the only way that they can essentially decrypt it is if a large enough threshold of these wardens participate in this protocol. And on the other side, the reason we don't just do it with standard Shamir secret sharing or something like this, and with NPC instead, is because if we would just have standard Shamir secret, we would basically have a way where wardens would be able to reconstruct that public key if on-chain consensus is found, and then they would be able to decrypt whatever they want, which would be a huge trust assumption. So instead, what we do is we have an NPC protocol that basically runs a computation, and this computation is quite simple. It basically just says, in an encrypted manner, sort of similar to how some listeners might be familiar with homomorphic encryption, runs the following program. For a given encrypted transaction flow, decrypt it internally, so to say. And if the decrypted actor is the sanctioned or the voted on malicious public key, basically output this specific transaction. And if not, do not output it. And the important thing to specify is that when I say internally, I don't mean like on the local warden hardware, aka the runners of the Warden can see what's being decrypted here. It really is internally similar to how FHE is, meaning that before the transaction is output, no one can see what the actual parameters are that are going on inside of the computation itself.
I have to interject a couple of questions here.
Yeah, for sure.
Please do.
Well, there. I mean, it's a little bit of like an aside, right? From the technical stuff. When you guys sat down at that restaurant and sort of said, "Hey, what are the problems here that we want to solve?" Were you guys, cryptography experts at the time? Or was this like, hey, we know we want to solve this problem and we're going to go figure it out and we're going to learn how to do this stuff?
I mean, we weren't cryptography PhDs or anything by that sense. I mean, both I and Yannick already had some experience with cryptography, just from, on one hand, me having worked basically through that TEE stuff at the company I worked at earlier. There I had basically, since it's all TE, I had to learn how to implement all these signing algorithms and key derivation algorithms and all that stuff basically from scratch, because in a TE you have nothing. So through that I got to work with a bunch of really talented people and learn a decent chunk of cryptography, obviously, which I then further developed going through university. Yannick himself also was studying math as his minor. So through that he also had a decent amount of experience. But basically, no. For us, it was basically starting out and saying, okay, this is a problem we want to solve. Let's get it done as good as possible. And yeah, we were lucky that we were able to raise funding. And through that, we were able to hire some super smart cryptography people to sort of help fill in the gaps that we had in our understanding there. Yeah.
Hey, let's have a brief intermission to thank our sponsors. We are super excited to be sponsored by Underdog Protocol. Underdog Protocol makes it really easy to mint, manage, and index digital assets on Solana. It's ideal for developers and startups. They offer gas-free NFT minting, airdrops for tokens and NFTs, and have embedded wallets. You're in great company using Underdog. We use Underdog, Solana Mobile, Solflare, and plenty of others do in order to simplify their NFT workflows.
Yeah, it's so simple to mint NFTs with Underdog that this is our code right here on the Solfate website of how we actually mint the podcast episodes as NFTs. Making a simple post request to the Underdog API. If you want DevNet or Mainnet, both are supported. And you just pass in your authorization token that you get from the Underdog dashboard, and then just provide in all the body details of all your NFT details. And then it mints it right away to the blockchain. Compressed NFTs, the simple API call. Check out Underdog and try it out.
That's cool. The primary reason I ask is I just I feel like we're gonna have a lot of listeners who are like, oh, I'm fairly technical, but this is a thing that I don't understand, right? Like this is
absolutely
this is next level, right? And I like hearing that. Hey, this is something you can just build on over time. You can learn more. You can just bit by bit, and it's something that most of us would be able to grasp given enough time and effort, right? I just want listeners to feel like, hey, if this sounds cool to you, you can go learn about this too, and get to the level of knowledge that Nico here has, because you clearly understand what you're talking about in a way that I, for example, I'm tracking at a very high level, right? In a broad sense. For example, you're talking about two different modes of basically reconstructing a public key. One that would allow wardens to reconstruct a public key themselves, versus another where you've got to reach some threshold of multiple wardens participating, right? I don't know the specifics there. And I imagine a lot of listeners are in the same boat as me, where it's like, hey, I'm a developer. I can figure stuff out, but this is new to me. And if that's scary, I want them to feel like they can push through that, if that makes sense.
Yeah, for sure. And I think another thing that's important to mention here as well is that, especially thanks to ZK and FHE and all this stuff having gotten relatively popular, especially thanks to blockchain technology more recently, there's tons of awesome tooling out there that essentially allows you to work with this stuff without needing to have a super deep understanding of it. Because, ZK technology has been around for, I think, more than a decade or more than 2 decades at this point. However, basically, if you want to work with ZK 5 years ago or 10 years ago, it would be super hard because you would have to understand everything down to a T. But nowadays, with languages such as Circom that some listeners and you guys might have heard of, or Nor by Aztec, there's a ton of languages. Well, I mean, basically what Circom and Nor is it allows you to write zero-knowledge circuits, so zero-knowledge programs, basically. It takes care of...
That's cool.
Essentially, it allows you to write it in sort of like a C-like syntax, kind of, and then compiles it down to a zero-knowledge circuit for you, and then allows you to generate the verifier key and the prover key, and most of the stuff for you. So it essentially takes away 90% of the math and whatnot. Makes things significantly easier.
What I want to know what some of these acronyms are that you've mentioned, and some of them you said, but it was relatively quick. So FHE stands for what?
It stands for fully homomorphic encryption. So fully homomorphic encryption is sometimes also called the holy grail of cryptography. And basically the idea behind that is saying because usually the thing that you often have is you have encrypted data, and then you want to do some computation on the encrypted data. But that usually requires you to decrypt that data, do your computation, and then re-encrypt it. And this, usually leads to vulnerabilities because what if someone attacks your system the moment you decrypt your data or whatnot? And so fully homomorphic encryption...
There's that momentary pass in memory that, the data is unencrypted for some, milliseconds, microseconds, whatever it is. So someone could attack your system and steal it out of memory.
For example, exactly. And so fully homomorphic encryption is basically a way with which you can keep your data encrypted and perform computation on it without needing to decrypt it in the first place, which, in my opinion, sounds super impressive, and it is.
Mine too. Like, that is wild.
And so basically the difference between there's something called fully homomorphic encryption and semi-homomorphic encryption. And, I guess it's a bit of a tangent, but fully homomorphic encryption basically allows you to do pretty much every type of computation on it. Semi-homomorphic encryption, as the name implies, only some kinds, but in that sense is significantly faster. And so, for, I guess, super technical listeners, what we use under the hood for us is only semi-homomorphic encryption. But there's tons of protocols nowadays coming out using the fully homomorphic version.
Got it. Okay, that's super cool. Another acronym you mentioned is NPC. And there are, we're not talking non-player characters, I don't think. So,
nope. As in Mike. Multi-party compute.
Oh, MPC. Okay, got it. Multi-party compute. Great. I heard N. We can continue.
James, you're such an NPC.
Totally.
Can you make sure you're trying to clear up, James?
Those were the two acronyms in my head that I was like, I need to know what's going on here. Anyway. I have plenty of questions here. I don't want to derail from the even further, that is from the track we were going with, explaining the how this works. Nick, did you have more how this is working questions?
No, I think you've kind of, Nico, you've kind of answered all of my, high level, naturally, how all of these work. And I definitely wouldn't understand the technical aspect of it. I don't understand cryptography at all. I do think it's wildly impressive, to say the least. So I do have more questions about the Warden nodes, who runs those? How do those work? Can anyone opt in to running one of these? How does the Warden network, so to speak, actually work, and who runs them?
Yeah, for sure. Yeah, so the Warden network, if it would be specific people that are chosen to run them or something, that wouldn't be very good, because obviously... it would be easy to attack. So in that sense, you can think of it decently similar to how most blockchain networks work today, that anyone who wants to run a Warden node can do so.
What's the incentive mechanism for someone to do that? Or is that still being built out?
So the incentive mechanism to run such a Warden is that whenever someone makes a small on-chain proposal, they pay a small fee. What this essentially does on one hand is prevent spam, because otherwise a bad actor could just make 1 billion proposals, and it would take a while to go through all those. And on the other hand, Elusiv itself, because Elusiv isn't just the privacy thing, the main thing that compliance thing, the main thing that Elusiv is used for is obviously generating privacy. And when you interact with Elusiv, you pay small fees. And if you run such a Warden, you're entitled to gaining certain shares of those generated fees.
Oh, that's cool.
Got it. So like if I execute a transaction on the Elusiv network, there's sort of Elusiv specific fees that would go to the wardens, or some portion would go to the wardens.
Exactly.
Okay. Yeah. So in that sense, it is very similar to, like you mentioned this, very similar to sort of a traditional blockchain blockchain setup. I guess I was wondering if all of it came from, like you mentioned, fees that you pay when you make a proposal, or some other form of mechanism there. How, I guess, what is the additional cost to gain privacy via Elusiv versus just a traditional transfer, for example?
Yeah, for sure. So I think there's two answers to this question. Right now, the additional cost is about 60 times what a normal transaction is, which sounds like a lot because it is a lot. And the reason it is a lot is because at the moment, Solana does not support syscalls for all the ZK proof verification stuff that we need to do. However,
soon TM.
Exactly. The cool thing is that starting in version 1.17.5, I believe is what the feature gate says exactly, Solana is adding 3 super important syscalls, or at least for us, which is outBN 128, which is essentially the curve that we're doing all the ZK stuff on, point compression, which allows us to use less space in the transactions, and Poseidon hashing, which is some special hashing algorithm that we use for ZK. And basically, once we can implement those and make use of those, one Elusiv transaction will be able to fit, instead of 60 transactions, inside of one transaction, which means that the core transaction itself will be exactly the same cost as any other normal Solana transaction. However, outside of that,
nice.
I know, right?
That's super cool.
Exactly, but outside of that, small fee, but nothing too enormous. Probably similar to what you'd expect from doing a swap or something like this.
Got it.
Yeah, even though it might be currently 60 times the normal transaction fee, with a transaction fee that's already so low, like if you're signing 1 or 2 signers, you're paying like 5 to 10,000 land ports, not including priority fees and stuff, but it's already super low. So like 60 times that is still a fraction of a penny if you were to convert that to most currencies. So still easily scalable from the financial aspect. So.
Well, and if the goal is to get like a private wallet, right? It's like you could do that with a single transaction, and then you have this sort of wallet that's ready to go, that's private, at least for now, assuming you don't do something stupid and get voted out of privacy. So yeah, it's a relatively that sounds very affordable. And Nick actually was the first person who told me about Elusiv almost a year ago. So like I can vouch for Nick when he says that he's like super interested in what you guys are providing, because he talked to me about a year ago. And the thing that it got me really excited is like, I think there are people who are like, what does privacy matter if you have nothing to hide? And while I understand that to some extent, there are plenty of reasons to want some amount of privacy. The one that I sort of personally use as an example is like, I run a small business, and I don't necessarily want all of my business transactions just there for everyone to see. I don't personally care as much about my personal transactions being visible, but with the business, where it involves many different people and multiple clients, some of which, maybe they don't want it public that we're working together yet. It's like, it gets a little tricky when I'm taking payments on chain, right? Or paying subcontractors on chain. Those are absolutely transactions I would like to keep private. And I don't think that means that I'm a bad actor. Right. So like I'm super interested in using this. How I'm curious, like I actually haven't gone through the process yet. And so it's like, I'm curious to know from a user perspective, is this, you just go launch the app on Elusiv's website and go execute transactions as normal, or what do I need to know or understand as a user jumping in and trying to do transactions with Elusiv?
Yeah, for sure. So right now, if you want to use Elusiv, the first step that you do is you go to our website, and up there you'll see a little button that says Top Up, and that basically allows you to deposit from a number of assets into your so-called private balance. And then once you have assets inside of your private balance, you can send them to someone else without obviously that person being able to see that those assets belong to you. Or we also have a swap feature, which is an integration with Jupyter, which allows you to essentially swap one token for another without someone else, again, being able to track that you're the one who did that. However, what I think is getting back to the syscalls, because that's the thing I'm most excited about for sure about this year, will enable a ton of other use cases. Because right now, the biggest problem with Elusiv about this 60 transaction thing is actually not the monetary cost necessarily, as you guys said yourselves, because Solana is super cheap, but it's more so the loss in composability. Because the cool thing about Solana is that you can take one transaction and you can put 6 instructions in there, and all of them call a different program, and they all work together to make some cool thing happen. With Elusiv right now, you can't do that because Elusiv has to wait for 60 transactions to complete for one actual action to have occurred. And so to combine that with other existing programs is a ton of work. However, once syscalls will be live, you'll be able to have that same type of UX of basically saying, I take funds from my private balance and I use those to call not just Jupyter, but for example, MarginFi, or I use those to call, make a perp trade on Zero markets or something like this. And so what we're most excited about that is to get some upcoming integrations with some wallets, because at that point, it won't be you have to use Jupyter through the Elusiv special front end, but rather you can have a private balance inside of your wallet, connect your wallet to the front end of whatever app like you normally would do, and then basically use that app like you normally would. And then when it comes time to execute privately, you can just do that using your private balance, since everything fits in one transaction.
Nice. Okay. I think I'm getting that. That's really awesome. I don't know that people appreciate that as much as they should. Like the how important smaller instructions is for composability, right? Like limiting the amount of compute required for a specific thing so that you can do many atomic things in one transaction.
Yeah, I mean, I think the reason it's not as much appreciated is because like the normal compute limits that Solana gives you allows you to do a lot of things. The only problem is if you're doing stuff which is, the ZK, which unfortunately isn't that optimized in most traditional architecture, only then you really start to see problems, which in my opinion actually really speaks for Solana that they were able to build such an optimized system that so many applications can run on it seamlessly. And on the other hand, that when they don't, such as in the case of Elusiv needing so many transactions, that they are rapid to work together with us and implement syscalls like this to allow those things to happen smooth.
Nice. I am. So one other question I sort of have as like a potential user, right? Is what level of communication with or information from governments or compliance groups has Elusiv had, right? So it's like, is this at a stage where you've mostly focused on building out the tech and you're not personally worried about is this enough in the way of compliance for most governments, and you're just sort of like assuming that it is, or do you have conversations with government agencies to discuss whether or not this is like a sufficient solution for them to feel comfortable with it?
Yeah, that's a good question.
For sure. I mean, yeah, great question for sure. So, as mentioned, like one of our big things is Zeus, and like it wouldn't be very smart from our end to, be building Zeus with sort of our head in the sand and being like, yeah, this will probably be fine. So of course, since, in crypto, you never have 100% guarantees about anything. And, especially with privacy crypto and whatnot, it's always still a little bit of a gray area. We've definitely invested a good chunk of time and resources in interacting with, lawyers and regulators and stuff like that to be as certain as possible that, this system, is compliant.
Awesome. So in the conversations you've been having, it's like you've gotten relative, positive feedback that the ability to unmask unmask certain wallets and transactions as needed is enough to sort of make regulators comfortable with this sort of privacy system.
Yeah, exactly. Because if you sort of look at what regulators have been saying in like more public communication as well, generally what they say is more so along the lines of we dislike privacy protocols or just like pure mixers and don't have any way to sort of interfere or regulate that type of privacy. But on the other hand, that also means they publicly say we support privacy protocols that innovate in that sense and allow for ways with which we can enforce stronger defenses against bad actors misusing this type of protocol.
Yeah. I think there's probably a certain type of like crypto user who worries that governments just want to like see everything regardless, and so that any privacy would be a problem. But I don't know that I see that as a tenable position for a government regulator, right? It's like there'd be too much backlash, I think, against that. When faced with an option like Elusiv, where it's hey, we have the best of both worlds. We can enable you to see what you need to see and do what you need to do, while also protecting the privacy of your citizens, right? Which supposedly is a thing that maybe not all governments, but most governments, I think, in modern society, like claim to care about the privacy of their citizens. So
Yep.
Probably a good thing.
All right, we're getting pretty close to time here, Nico. We want to be super respectful of the amazing time that you've given to us and our audience to talk about everything Elusiv and ZK here. I am personally very appreciative. This is so cool, and I'm personally a user of Elusiv. I think it's really, really cool, and I'm real excited for those 1.17 improvements and those syscalls. And I guess the last thing is if there's anything that you want to mention that you haven't gotten a chance to talk about, or last minute chills, we're all ears.
No, I mean, keep posted for Elusiv V2. It'll be awesome. Thanks so much for having me as well, guys.
Is there a timeline on that?
Basically, as soon as ZK syscalls get activated.
Okay.
Yeah.
So it's more or less ready to go on your end, and you're just sort of waiting for Solana updates.
Yes, correct.
Awesome.
Nice.
Way cool. Well, hey, I think it speaks volumes to Solana, the community, Solana Labs. That like you said, they're continuing to innovate and enable such a dramatic improvement for people, right? Like a 60x change in like you were talking about is huge. So that I think that's awesome of Solana. I think I loved the part of your story where you said, hey, we presented at the Miami Hacker House and like maybe weren't expecting this, but it was like a standing ovation and everyone wanted to talk to us. And like, it was like, oh dang, we struck a nerve. We like found a thing that really matters to people. And let's lean in. So I think that's awesome. I think over the next few years, Elusiv is, I can't see how it wouldn't just like take off and become a standard thing for people to use, because we all want absolutely. To like continue using, we want to continue having transactions on chain. The more we start to bring our like personal finances on chain, the more people are going to be like, hey, actually, I want to keep some of this private and we'll utilize something like Elusiv. And as far as I know, I don't know of any competitors who are building out solutions that work like this and enable both privacy and compliance. So this is really awesome. Thank you so much, Nico, and thank you to your team for what you guys are building. But yeah. Anything else?
Thanks so much for having me.
No, all right. No, this has been great. Thank you so much for joining us. And like we tell most of our guests, like you guys are welcome back anytime. I'm sure that we could come up with many more questions and maybe even dive into actual more technical things, not just high level technical things. That'd be fun.
Yeah, I could do some cryptography learning first.
Cryptography 101 with Nico. I like it.
Nice. All right. Well, to the listeners, we'll see you guys next time. Thanks again, Nico. We'll hopefully chat again soon.
Bye-bye.
Have a good one. Bye bye.